Welcome back. In this section, we'll be talking about solving quadratic equations. You might have noticed that this is section 2.5, that we've skipped over section 2.4. In the textbook, section 2.4 covers complex numbers, which is not part of this course, so we are omitting it. If you want to read 2.4, you certainly can for fun, but I'm not expecting anyone to know the material from the section on complex numbers. So, quadratic equations. Those are just equations where the degree is 2. So in other words, where the highest power on the variable is power of 2. And we'll be looking at solving quadratic equations in one variable. So just a single variable, highest power is 2. These quadratic equations could all be rewritten in this form, where a, b, and c are real numbers. There'll be an x squared term, there might be an x term, there might be a constant term. Here, b and c might be 0, they might not be. A can't be 0, because of course if a was 0, that would mean you wouldn't have an x squared term, which would mean that you wouldn't have a quadratic. So maybe I might want to make a little side note here saying, rewritten in this form where a, b, and c are real numbers, and a is not 0. Okay, so ways to solve quadratic equations. There's 3 ways that we're going to look at. In this video, in the first half of 2.5, we'll look at solving by factoring, and in the second half of this lecture, in the part 2, we'll be looking at using completing the squares method, as well as using the quadratic formula. So to start by factoring, this is basically using the zero product property, that when things multiply together to give us 0, then the individual factors themselves need to be 0. The important thing here is that we are going to solve by factoring, and we're going to solve by factoring after we've moved everything to one side where we have 0 on the other. That's our goal here. Now, that doesn't mean that this will always work. Just because you can't factor something doesn't mean there are no solutions. That's why we've got the other approaches to solving. We've got the other techniques that can be used. But because factoring is fairly fast to work with, if you can factor, then why not? So, solving the first equation, and I'm going to do this the correct way, and then I'm going to talk about a mistake that some people might make. So I'll make a little divider here. I'll do it the correct way on the left side. If you were to solve by factoring, if I were to bring that 4x over to the other side, I would have everybody on one side and then equal to 0 on the other. I could then factor the x out. And that means that I can conclude that either x is 0 or x minus 4 is 0. Or in other words, either x is 0 or x is 4. So for our solution set, it contains 2 numbers, 0 and 4. Notice the notation that we're using for solution sets. We're using curly brackets. The little curly brackets around the 0 and the 4 tell me that these are a set of numbers. This isn't a point. This is not the point 0, 4. This is not on the x and y plane. These are 2 different x values that are possible solutions to this equation. And same thing as with all the equations that we solve. Again, you can go back and check your answers. You can find that if you were to put 0 into this equation, it would make left side equal to right side. And if you were to put 4 into this equation, it would also make left side equal to right side. So you can feel confident in your solutions that they are 0 and 4. Now, if we were thinking about solving this, somebody might be thinking about using this approach. They might say to themselves, well, you might say, why don't I start off with my equation x squared equals 4x, and I can divide both sides of the equation by x, so I'll do that. And then I've solved it, and I found that x is 4. The problem is that you'll notice you only found one of the 2 solutions using this approach, and so you might ask yourself, where did the other solution go? And actually, the other solution vanished when we divided both sides by x. I'm going to do a little bit more writing this time. If you divide both sides by x, you are now making rational expressions. And remember, for a rational expression, those are undefined whenever the denominator is 0. So if you've divided by x, then you're assuming that x cannot be 0. In other words, by dividing by x, you've thrown away that other solution. This is why when we're solving equations, we don't solve by dividing, we instead solve by factoring. If you divide by something that could potentially be equal to 0, then you're eliminating that as a potential solution, and that's not what we want to do. So this approach of trying to solve by dividing, no thank you, we will not be doing that. We'll instead be solving by factoring. So the correct answer is for this problem that this solution set contains 0 and 4. One more to solve, and again we'll solve this much the same way. I'll be bringing everybody to one side, so the x squareds have been brought over to the left side, leaving me with 3x squared. I bring the x over to the left side, leaving me with 19x, and I bring the 14 over to the left side, and so now the right side of the equation is 0. And I just need to solve this by factoring, and I know that if I were to solve by factoring with this kind of equation, 3x squared plus 19x minus 19, I would be needing to find two numbers that multiply together to give me whatever 3 times negative 14 is, which happens to be negative 42, and that I'd be looking for numbers that add up to whatever the coefficient of x is, which is positive 19. So I need to find numbers that multiply to negative 42 and add up to negative 19. And the two numbers that I'm going to choose are 21 and negative 2. And just to double check, positive 21 times negative 2, yes, that multiplies out to negative 42. Positive 21 plus negative 2, that adds up to 19. Okay, so now we can continue. 19x is going to be split into positive 21x and negative 2x. And now factor by grouping. First two terms, I can take out 3x, and that leaves x plus 7 left over. The second two terms, I can factor out negative 2, and that leaves x plus 7 left over. And that means that our choice of two numbers was done correctly, since x plus 7 is in common to both. Remember that if you're trying this approach of factoring by grouping, if what's left over doesn't match, then you did something wrong, and usually the something is you picked the wrong two numbers. So here, the two numbers that we picked, 21 and negative 2, do indeed work, because we're left with x plus 7 in both of the terms, so x plus 7 can factor out of both. And in the first term, we're left with 3x left behind, and in the second term, negative 2 is left behind. So now we've got it factored out and equal to 0. So either x plus 7 is 0, which is negative 7, or 3x minus 2 is 0, which is that x is 2/3. So our solution set contains two values, positive 2/3 and negative 7. Just as a little side note here, when you're listing values in a solution set, it doesn't really matter what order you list them. In a set, the order doesn't matter, so if you put the negative 7 first and the 2/3 next, that's fine as well. Doesn't really matter as long as you're listing all the solutions that you found inside your solution set. Now, this square root property, this is a useful property, and it's got two parts to it. First is if we have something like a squared equals to b, and you were trying to figure out what could a happen to be, remember that for a perfect square, something to be a perfect square, there are two numbers that will take you there. So for example, if you knew that x squared were 9, there's two possible numbers that you could have that would, when you square it, would give you 9. X could be positive 3 or x could be negative 3. In other words, x could be the positive root of 9 or x could be the negative root of 9. And that's the idea that we have here for this square root property, that if we have some sort of expression a squared equals b, then a is either positive root of b or the negative root of b. Now, this of course is only true if the thing that we're taking a square root of happens to not be negative. If it turns out to be negative, so for example, if we had x squared equals to negative 12, then I wouldn't say that it's the square root of negative 12 for our answer, because that's not a real number. There's no real number that when I square it would give me a negative. Any number when you square it would give me a positive, so something like this would have no solutions. That would be an example of an inconsistent equation. Okay, so let's use this property to solve some equations. First one, solving for x, I'll bring the 15 to the other side. I divide both sides by 5. That gives me x squared is equal to 3. And so that means that there are two possible solutions. Either x is the positive root of 3 or x is the negative root of 3. So my solution set contains two values, positive root of 3 and negative root of 3. The reason why I'm using this approach to solve here is if we tried to factor, 5x squared minus 15 doesn't really factor apart from being able to take out a common factor of 5. What's left over is not a nice difference of squares or anything nice that factors out. So this is the approach that we take instead. Also, just to reiterate what I've said a couple of times already so far in this course, things like square root of 3, we're not going to run to our calculator and figure out what that is as a decimal, because all I want is the exact solution, and so the exact solution is square root of 3 and negative square root of 3. If you give me the decimal value, approximately 1.7, that's an approximate value. That's not what we want. That's close to the true answer, but that's not exactly the real answer. The solution to this exactly is positive root of 3 as well as negative root of 3. Now for the second one, x squared plus 1 is equal to 0. If we were to think about trying to factor this, we know it doesn't factor. It's a sum of two squares, so too bad for us. And if I try to use the square root property by first bringing the 1 over to the other side, then I can see immediately that there are no solutions to this. X squared could not be possibly equal to negative 1. There are no values that when I square them that give me a negative for real numbers, so that means there are no solutions. I should be more precise. I should say that there are no real solutions. And so the reason I know there's no real solutions is because if you tried to solve for x, you would find that x is the root of negative 1 or the negative root of negative 1, and that's not a real number, and that's also not a real number. Square roots are only defined when the inside of the root is the square roots are only real numbers when the inside of the square root is not negative. So here we can say that there's no real solutions. And one last one to do before we take a break. So solving this, you might look at this and think to yourself, oh, I'll expand what's on the left side and it'll give me some sort of a polynomial, and then I'll try to factor it. But look at what we can do with that square root property. And I could first bring that 75 over to the other side. And then I could divide everybody left side and right side by 3. So now I've got something where it's a perfect square equals to 25. So that means that what's inside that bracket, the 2x minus 1, is either going to be equal to the positive root of 25 or it's going to be equal to the negative root of 25. Or in other words, 2x minus 1 is either equal to positive 5 or it's equal to negative 5. And now I just need to solve for x. So bringing the 1 to the other side and solving for x, bringing the 1 to the other side and solving for x. I find that there's two solutions to this. So my solution set contains 3 and negative 2. There we go. And of course, as always, you can check your solutions by seeing if you were to substitute 3 into the original equation, does it make left side equal to right side? If you substituted negative 2 into the original equation, does it make left side equal to the right side? And yes, it does in both of those cases. So this is where we'll pause, and when we come back in the next video, we'll talk about completing the square and the quadratic formula.